Hello, my name is Max. I am a math tutor at LSC-Montgomery Star Center, and in these series of videos, I will be going over the TSIA2 math portion. In this session, we'll be going over algebraic reasoning. So on the TSI, there will be a lot of questions in equation form, and we have to solve that equation. So if we look at this question here, it says given the equation, solve for x. So we have 3 to the x power minus 2 equals to 25. So you have to be careful of how we read this. It's 3 raised to the power of x. So our x is the exponent. It's not 3x. So to solve this, like any equation involving solving for x, we want to isolate our variable x. So first thing we do is we need to get rid of this negative 2. To get rid of something in math, you always want to do the opposite term. So if it's a negative 2, we would add 2. And what we do on one side of the equation, we need to do to the other. So we add 2 on both sides. Because what's going to happen on the left side here is negative 2 plus 2, that is 0. So they 0 out. We're left with just 3 to the x on the left. And 25 plus 2 gives us 27. Now, as of right now, there is no set way to understand how to solve 3 to the x equals 27. What we can do though is we can use our understanding of exponents to find out what x has to be. Because when we're saying 3 to the x is equal to 27, we want to ask ourselves, what would x have to be so when you raise it to 3 to the power of that, we get 27. So then you can start listing the powers that we know. So 3 to the power of 1, that's just 3. 3 to the power of 2, we know that's 3 times 3, which gives us 9. But then 3 to the power of 3, that's 3 times 3 times 3. Now, 3 times 3 is 9, times 3 again gives us that 27. So using kind of intuition and understanding of exponents, we can say that x equals to just 3. And that is how we get to answer choice C. Now let's look at solving a very common type of equation, a linear equation. So to solve this equation, we have to use what's called order of operations, or PEMDAS. So PEMDAS stands for parentheses, exponents, multiply, divide, add, and subtract. So that's the order we want to use in order to solve equations. So first thing we look at is we have 4x minus 5 plus 7 parentheses x plus 1 equals to 6x plus 7. So first thing we look at is our p. P stands for parentheses. So the only thing we see in our parentheses though is x plus 1. We can't do anything with that because they are not like terms that we can combine. However, if you look right outside the parentheses, we have a 7. So we can use distribution rules to distribute the 7 into both terms on the inside of the parentheses. So if we rewrite everything, we would have 4x minus 5 plus 7 times x, 7x, and 7 times 1 is 7, equals to 6x plus 7. Now we want to look at both sides and we want to combine any like terms that we have. So if we follow the order of operations, we don't have anything to multiply or divide yet, but we're doing the adding and subtracting because we can do them at the same time. So on the left side here, we have 4x plus 7x. They're like terms. We can add them. That gives us 11x. And then negative 5 plus 7, that's like saying 7 minus 5. That's positive 2. Equals to 6x plus 7. So now we have an x on the left and on the right. We need to consolidate them, or we need to bring them over to one side. So let's say we take the 6x and move it over to the left. So we do that by subtracting 6x on both sides. So we can put that negative 6x right under the like term 11x. So on the right side, these kind of cancel each other out. And 11x minus 6x gives us 5x plus 2 equals 7. And now our x, we're going to isolate our x, so we need to get rid of plus 2. So we do that by subtracting 2. We do it on both sides. So this cancels out. We get 5x, 7 minus 2 is equal to 5. Now, we want just x by itself. To get just x by itself, we look at the 5. The 5 is a coefficient. So that 5x, it's 5 times x. So the opposite of multiplication is always going to be division. So what we would do is we would divide by 5. And again, what we do on one side, we do to the other. And why do we divide by 5? Because 5 divided by 5, anything divided by itself, is always going to be 1. And we want 1x because 1x can be written as just x. And if we coincidentally, if we divide 5 by 5 on the right side, we get just 1. The solution of this equation is x equals to 1, which gives us answer choice C. So another question says, write the equation of the line in slope-intercept form with the line passing through the point -1, 4 and m equals to 2. So to solve this problem, we need to understand what is slope-intercept form of a line. So slope-intercept form is a very common form you would see linear equations in. So that form is y equals to mx plus b, where m is called our slope and b is what's called the y-intercept. So to understand what that means is the slope of a line is if we have a line here and we graph a linear equation. Now, the slope is if we have 2 points on that line. We have a point here and a point here. The slope of it is the change in the y over the change in x. So that means how much we're going in the y amount direction and how much we're going in the x direction. A lot of times the more common way to phrase a slope is the rise over the run, or the change in y over the change in x. Now, y-intercept is the point on the line on which the line crosses the y-axis. So in this particular case here, this point would be right here. And that point is always represented by point 0, comma b. So x will always be 0, and our y value would be some b value. So going back to our question here, to look at this, is we're given some pieces of information. We're given that our slope is m equals to 2, and whatever our line is, it passes through this point -1, 4. So right away, we're given that m is equal to 2. So if we write our equation in slope form, we know it's going to be 2x plus some b. So we need to figure out what that b is. To figure it out, we would use the given point here, because we know a point is always written in as an ordered pair of x, y. So we know this is going to be our x and this is going to be our y. So we can actually take that x, y and plug it into our equation here. So if you plug y as 4 and plug x as -1, we can now solve for b. So 2 times -1 is -2 plus b equals a 4. So we can add 2 both sides to move it over to the left. Cancels our here. 4 plus 2 is 6. So that's our b. So if we take our b and plug it back into our slope-intercept form of our equation, you would get 2x plus 6. And that would be the equation of the line in slope-intercept form. And that would give us answer choice D. So now another type of question you might encounter is solving a system of equations. So when we're solving a system of equations, unlike when you're solving just like a linear equation, not only are you solving for x, but you're also solving for y. So you're trying to find an ordered pair. So we notice our answer choices here are ordered pairs. So there's a couple ways to solve system of equations, but the way, if we look at what we have here, so we have y equals to negative 3x plus 6 and y equals to x plus 2. Now notice both equations are y equals. They're actually in, kind of like we talked about earlier, slope-intercept form. So they're both y equals, so we can actually set them equal to each other in order to solve for x because they're both y equals. So we can set the first equation is negative 3x plus 6, equate that to the second equation, x plus 2. So now we have an equation where there's only a singular variable of x, and we can solve for it. So let's move this x on the right, move it over to the left side. So we do that by, again, subtracting x on both sides to get rid of it on the right. So what's going to happen here is the x's on the right are just going to cancel out. And we're left with negative 3x minus x gives us negative 4x plus 6. That's equal to 2. Now to get x by itself, we want to get rid of the positive 6 by subtracting 6. And we do it to both sides. Again, this cancels. Negative 4x equals 2. 2 minus 6 is negative 4. And in our last step, just divide by negative 4 to get x by itself. So negative 4 divided by negative 4x divided by negative 4 gives us x. And negative 4 divided by negative 4 is a positive 1. Now we have our x value, but we need to find the corresponding y. So how we do that is we plug this x equals 1 into either of our two equations up here on top. It doesn't really matter which one we plug it in. So for simplicity's sakes, we can plug the x equals 1 into the second equation here. So let's do it on the side. So we have y equals 2, x, which is 1, plus 2. So 1 plus 2 is 3. So our y equals to 3. So our answer, as an ordered pair, be 1, 3. Which would be answer choice B. So another system of equations question. We want to solve the following system of equations. We have 2x minus 3y equals 0, and negative 4x plus 2y equals negative 8. Now, comparing this question to the previous one, it's a little bit different because, unlike the previous one, these two equations are not in the y equals form. So we can't simply just set them equal to each other like we did before. So we would have to use another method to solve it. So another method to solve system of equations would be what's called the elimination method. So how the elimination method works is we try to eliminate or get rid of one of our variables, and then when we add the two equations together, we just get one variable and we solve for that singular variable. So how we do that for this is, let's look at our x's and y's kind of separately here. For our x's, we have 2x and a negative 4x on the second equation. And then for the first equation, we have a negative 3y, and second equation, a positive 2y. So what if we went ahead and made that 2x into a number so that when we add it to that negative 4x, we get 0. So that 2x can be turned into a 4x because 4x minus 4x gives us 0. So to turn 2x into 4x, we would have to multiply it by 2. But we can't just multiply just the x by 2. We have to multiply everything on that first equation by 2. So using elimination method, we'd multiply this by 2. So let's go ahead and rewrite our first equation after we multiply by 2. So 2x times 2 is 4x. Negative 3y times 2 is negative 6y. And 0 times 2 is still going to be 0. And let's rewrite our second equation. Negative 4x plus 2y equals negative 8. So now, part of the elimination method is once we did that, we multiplied them, we would add the two equations together. So just think of this as like you're adding it. So we add only like terms. So 4x minus 4x is technically 0. Negative 6y plus 2 gives us negative 4y. And 0 plus negative 8, or 0 minus 8, is negative 8. So we're just left with negative 4y equals to negative 8. And to solve for y, we would divide by negative 4 both sides. So left side, we're left with just y. And negative 8 divided by negative 4 gives us 2. Well, what we just solved for is our y, but just like before, the solution to a system of equations has to be an ordered pair. So we need to find our x value, and we can do that simply by taking our y here and plugging into one of the two equations. So let's look at our original first equation, 2x minus 3y equals 0. Let's go ahead and use that to solve for x. So we take the y equals 2 that we just solved for, substitute it into our y. So 2x minus 3 times 2 equals 0. So we have 2x, negative 3 times 2 is negative 6. We can move the 6 over to the right side by adding 6. So 2x equals 6. And to get x by itself, we divide both sides by 2. So left side's x, and 6 divided by 2 gives us 3. So as an ordered pair, our solution to the system would be 3, 2. And that is how we get answer choice A. Let's look at an inequality problem. A cell phone company promotes a program that charges a flat rate of $20 per month plus 6 cents per call. Joe wants to spend less than $50 for the month on this service. What is the maximum number of calls he can make while keeping the total under $50? So let's break down this word problem part by part. The first part here is it says that he's charged a flat rate of $20 per month. So what that translates to is that no matter what his phone bill or how many calls he makes on his phone bill, so either he makes 0 calls or he makes 1,000 calls, he will always have at least that $20 charge. That's the first thing. In addition to that, he's charged 6 cents per call. So because Joe's trying to figure out what his phone bill has to be, how many calls he has to make to keep his phone bill under $50, our unknown variable here, what he's trying to figure out, is x would be our number of phone calls. Now, the next bit of information is in the next sentence, which says Joe wants to spend less than $50 a month. So the key thing here is because we're talking about his phone bill, he wants to keep his phone bill less than $50. So in math, when we see the word less than, we automatically think about the inequality symbol here, less than. That's the less than symbol. So if we kind of put everything together, let's create an inequality involving Joe's phone bill. So the first thing is we have the $20 per month, so the $20 charge, plus 6 cents per call. So in math, we always want to represent 6 cents or cents in reference to how many cents are in a dollar. So if a dollar has 100 cents, then 6 cents would be 0.06, because you want to think about it as like a percentage. If 100% is a 1, then 6% as a decimal would be 0.06. And now it's 6 cents, 0.06 per call, which means that you take the 0.06 and you multiply by the number of calls, which we call x in this case. And then now this is his phone bill. He wants to keep it under $50 a month. So we do less than 50. Right? So this right here on this left side, we can say that this left side here is his phone bill. With that being said, we can now solve for x here. So let's rewrite this on the right side. So to solve for x, we want to get rid of our 20 first, so we subtract 20 on both sides. Gives us 0.06x less than 30, and then we divide both sides by 0.06. So it gives us x. If you use a calculator, x would be less than 500. So now let's interpret what that means. Because x represents our number of phone calls, and he wants to keep his number of phone calls under 500 calls. Because if he goes more than that, if he goes on, let's say he calls 501, he would actually exceed his $50 budget. So Joe wants to just keep his phone calls under 500. So it could be like 499, 498, or whatever it is, as long as it's below 500. And then that will give us answer choice D. Now we want to introduce factoring. So factoring, when it comes to quadratic expressions or quadratic equations, is very important in algebra. So when we look at this problem here, this expression, x squared plus 4x minus 21, the instructions are to factor completely. So we have to recognize what this expression is. This expression is a quadratic expression. The quadratic term, it comes from the fact that we know that the highest power here is a power of 2. So this is written in standard form of a quadratic expression, x squared plus bx plus c. Now, oftentimes when you have a quadratic equation, let's say it's equal to 0 here, to solve that quadratic equation, what you have to do is you have to factor it. So that's what we need to do in this problem. So we want to factor it from a trinomial term, so 3 terms, into 2 binomial terms. So those two parentheses, they both have 2 terms each. That's what they're called, binomials. So how we do that is by this, the first thing we do is we can use the guessing and checking method. So the guessing and checking method is, in a way, reverse foiling. So remember, foiling, the FOIL method is, let's say for instance, for example, if we had x plus 1 times x plus 2. So if you were required to multiply these two terms, you would apply the foiling method. So foiling stands for first, outer, inner, last. So that's the order in which we multiply. So when you multiply x times x, that's our first, that's our f. X times 2, that's going to be our O, that's our outside. The inside is 1 times x, that's our I. And then the last terms are 1 times 2, that's our last term. So that's the FOIL method. So if you were to FOIL this, that gives us x times x is x squared, x times 2, 2x, and 1 times x is x, and 1 times 2 is 2. If we combine like terms, that gives us 3x plus 2. So that's what we're trying to do here. We're trying to go from this term back to the factored form. So that's what we need to do for this question. So how we do that is, we know that because the front number here, the first is x squared, we know it's going to factor into an x here and x here. Because again, x times x gives us x squared. Now, what our question is, what's going to go here and here? So what's going to go there is, we think of two numbers that multiply get you negative 21, but add to get you that positive 4 in the middle. So first thing you do is we're going to think about what are factors of 21. We know 21 is 1 times 21 and 3 times 7. But we're going to ask ourselves, which pair can somehow combine to get you a 4? It would have to be the 3 and the 7. So let's say we put 3 here and 7 here. Now the important thing now is our signs. We know that if we multiply 3, we're supposed to get a negative 21. So in order to multiply get you negative, one number has to be positive and one has to be negative. But the question is, which one? How we determine that is that middle term, that positive 4. Because the 3 and 7, whatever their signs are, they need to combine to get you a positive 4. So let's say, for instance, we have a blank 3, blank 7, and they need to combine to get you a positive 4. The only way for that to happen is if 3 was a negative and 7 was a positive. Because if we flipped it, a positive 3 and negative 7, that wouldn't get you a positive 4, that would get you a negative 4. So we would translate these signs up here to our factors. So it'd be a minus 3 and a positive 7. And that would be the factored form of our quadratic expression. Now the order of it doesn't matter. We can actually write it as x plus 7 first and x minus 3 second. The thing that matters is where the sign is associated with. The negative sign has to be with the 3, and the positive sign has to be with the 7. And that is how we would factor. And as you see, the answers would be B. Even though the order is different, the positive goes with 7 and the negative goes with the 3. Alright, so let's look at another factoring problem. This time, it looks a bit different from the last because we have 8x squared minus 22x plus 15. So compared to the last question where we had just an x squared, it would be easy to factor as x and x by using the guessing and checking method. Now we have a more complicated 8x squared. So why that complicates things is that when you're doing the guessing and checking, there's two ways to factor 8x squared. You either have it as 8x times x or 4x times 2x. We don't know which one pair to use. So instead of using the guessing and checking method, what if we try another method called the AC method? So the AC method, it comes from the standard form of a quadratic, and we say the AC method is we take the A term, the A coefficient, and the C coefficient, and we multiply them together. So in this case, we have 8 and 15 as our A and C respectively. So 8 times 15, that gives us 120. Now what we want to do is we want to find factors of 120 that add up to get you a negative 22 in the middle there. So if we notice, we will have 12 and 10. That gives us 120. And also, if you were to combine them, and so if you combine them as they are, you get a positive 22. But if we had both negatives, that would give us negative 22. So negative 12, negative 10, multiply gets you positive 120, and they add up to get you that negative 22 in the middle. So what do we do with these two terms? What we do is now we rewrite this as 8x squared, but now instead of writing negative 22x, we replace it with these two factors here. So we can write this as negative 12x minus 10x plus 15. And then from there, what we do is we want to group up the first two terms and the second two terms. So if we look at the first set of parentheses, 8x squared minus 12x, we want to factor out a common factor, the greatest common factor. So the greatest common factor between 8x squared and negative 12x would be a 4x. And when we factor it out, we're left with just 2x minus 3. Now let's look at the second set of parentheses, negative 10x plus 15. Again, find the greatest common factor, and that would be a negative 5. And then we factor that out. The reason why we pull out a negative 5, not just 5, is because the negative is in front right there. And we want to pull out that front negative. So we're left with, again, 2x minus 3. And then we notice that these two parentheses are the same. So when we're doing the AC method, you want to make sure that those two parentheses are always going to be the same. So we factor out that common 2x minus 3. And then essentially these are our leftovers. And we group up our leftovers. So the factor form of this quadratic is 2x minus 3 times 4x minus 5. Now, if you're not sure you factored correctly, you can always double check. We can always check if we did our factoring right by doing the foiling method. So if we FOIL, 2x times 4x, 8x squared, 2x times negative 5, negative 10x, Negative 3 times 4x, negative 12x, and negative 3 times negative 5 gives us a positive 15. And if we combine like terms, combine those negative 10x, negative 12x, negative 22x, and look at that. We get the original expression. So that confirms that this is the factor form of 8x squared minus 22x plus 15. And that will give us answer choice C. Let's look at another quadratic expression. This time we have w squared minus 144, and again, we need to factor completely. So if we compare this one with the other two quadratic expressions we had earlier, we notice that this one only has two terms. It has w squared and then a negative 144. So if you notice, this does not look like the standard form that we are used to. We're missing that bx term, that middle term right there with that b coefficient. So we could actually rewrite this quadratic to have a b term, because we can technically write this as w squared plus 0w minus 144. So now to factor this, we can use the guessing and checking method that we did previously. So we think about it, we know it's going to factor into w and w, because that gives us w squared. But now we want to think about what two numbers multiply get you negative 144, but add to get you a 0 in the middle. So we think about two factors, numbers that multiply get you negative 144. So we know that 144, the factors, the most common factors we know of them is 12 times 12. However, we know that it multiplies to get you a negative number. That means one has to be positive, one has to be negative. But when you add them together, they have to be 0. So numbers that add together to get 0 is if they're the same number but with opposite signs. So that means that we would have to have a positive 12 and a negative 12. So that would be our factor of w squared minus 144. And again, you can always check this by foiling, and you'll notice once you foil and combine like terms, you'll notice you'll get w squared minus 144 again. And that is why our answer would be answer choice C, w minus 12 times w plus 12. Alright, so let's look at another one, this time very similar to the last, where we have just two terms. However, this time our two terms are kind of more complicated numbers. They're bigger numbers to work with, because we have 36x squared minus 49y squared. Now, we could introduce a middle term here, but I think that would make it a little bit more complicated. Instead, we can factor this by using what's called the difference of squares. So when we're talking about difference of squares, what that is that when you have a squared minus b squared, we know that it can factor into a plus b times a minus b. So difference means subtraction and squares means power of 2. So this is a very common method to factor two difference of squares like this. A plus b times a minus b. So if we relate this to what we have here, we can say that our a squared term is the 36x squared, and the b squared term is the 49y squared. So we know that a squared is 36x squared. What would a have to be? So a would have to be whatever you square to get 36, which would be 6. And whatever you square x to be to get x squared has to be x. So it means that if we took 6x and we squared it, we would get 36x squared. In the same vein, for b, what squared gives us 49 has to be 7. And then what squared gives us y squared has to be y. So that would be 7y. Therefore, we can say that this expression can be factored into, using difference of squares, a plus b, a minus b. So 6x plus 7y times 6x minus 7y. And that would be our factored form of our following quadratic expression, which would give us answer choice C. So now we actually want to take it a step further with quadratics, and we want to solve quadratic equations. So just like any type of equation, we want to isolate our x value. So let's look at our equation here. We want to solve the following equation: x plus 9 squared minus 36 equals 0. So the first thing we want to do is we want to isolate the x. So let's move that negative 36 over to the right side by adding 36 to both sides. So in doing so, we would just left with x plus 9 squared equals to 36. So now we need to, our x is inside that power of 2 because it's x plus 9 quantity squared. So we need to get rid of that square, and we do that by doing the opposite of a square, which is a square root. So we apply a square root to one side, and obviously what we do to one side, we do to the other. So what's going to happen on the left side is that square, that exponent of 2, is going to cancel with the root, and we're left with just x plus 9. Now on the right side, so taking a square root of 36, we know it's going to be 6. However, it's not just 6, but it's also negative 6, because 6 times 6 gets us 36, but also negative 6 times negative 6. So we can represent that by saying plus or minus 6. So what's going to happen here is that this is we're going to get two equations out of this. We're going to get x plus 9 equals positive 6, and x plus 9 equals negative 6. So to solve this, we isolate the x, so we would subtract 9 on each side to get rid of that 9. So I'm going to do it over here as well. So what we're left with is x equals 2. So this will be a negative 3 for one of them. And the other one is x equals to negative 15. So, unlike solving linear equations, when we solve quadratic equations, we would always get two solutions. So our solution set, so it's written in curly brackets, would be both negative 15 and negative 3. Both answers would be our solution. And you can always double check that by taking these values of x's, negative 3, negative 15, and plugging it back into the equation, and you'll see it's true. So our answer would be both. Now the order of it doesn't matter. You can write negative 3 first or negative 15 first in our curly brackets, and it gets you the same result. Therefore, our answer choice is B. So for questions like this, we can see because it's a quadratic equation, answer choice A and D would not be an option because we need two solutions. So that kind of narrows our search down. Okay, so this one says, solve the equation 3x plus 6 divided by 3 minus 4x divided by x minus 3 equals to x. So whenever we're trying to solve any type of equation involving fractions, what we need to do is we need to find a common denominator first to kind of what's called clear our fraction. So we look at the two denominators here. We have 3 and we have x minus 3. So the common denominator would actually just be the product of the two. So we can say our LCD here is 3 times x minus 3. So what we do is we take our two equation and we multiply it by our LCD. Okay, so what we're going to do is we're going to distribute this LCD, this 3 times x minus 3, into every single term on the inside of our fraction. So I'm going to write this as 3 times x minus 3 times the 3x plus 6, and that's divided by 3, minus 3 times x minus 3, I'm just write times 4x over x minus 3, and on the right hand side, I'm just going to go ahead and just write this as 3x times x minus 3. So before we try to multiply anything in the numerator or try to expand it, let's see what we can cancel out. So in the first fraction, we see there's a 3 in front here, and that can actually cancel with a 3 on the denominator. And then on the second fraction, we have an x minus 3 on top and on bottom. That will cancel out. So once they cancel out, we have no more parentheses. Oh, we have no more fractions, because we're going to have just x minus 3 times 3x plus 6 for the first term. And we'll have 3 times 4x on the second term. And the right-hand side still stays the same. Okay, so now we want to expand our equation here. So on the first terms, we would FOIL. X times 3x is 3x squared. X times 6, 6x. Our inside is 3 times 3x, so negative 9x. And then negative 3 times 6 is negative 18. And if we distribute negative 3 times 4x is negative 12x. And then distribute the right-hand side, 3x into the parentheses, gives us 3x squared minus 9x. Okay, so let's combine like terms. So we have 3x squared still. We have a positive 6x minus 9x. That's negative 3x. And a minus 12x. So that'll be negative 15x. Minus 18 equals a 3x squared minus 9x. Okay, so whenever we're solving any type of quadratic equation, we need to bring everything over to one side and make the other side into 0. So let's take the terms on the right side and move it over to the left. So we would subtract 3x squared on both sides. And at the same time, we can also add 9x to get rid of that negative 9x. So what's going to happen here is we're going to get, so these two terms cancel on the right. So 3x squared minus 3x squared is 0. Negative 15x plus 9x is negative 6x minus 18. That's equal to 0. So to get x by itself, we add 18 both sides. So it gives us negative 6x equals 18. And the last step is divide by negative 6. So our answer here, x is going to be negative 3. And then because our original equation involves fractions, we want to make sure our negative 3 makes sense in our equation. So what I mean by that is that because in fractions we cannot have 0 on the bottom of our fraction because we can't divide by 0. So the question you want to ask yourself is when you look at your solution is if you take your solution, in this case x equals negative 3, and you plug it into any of our denominators, will we get 0? In this case we won't, because the first denominator is just 3, nothing to plug in. The other denominator, x minus 3, when you plug in negative 3, that's negative 3 minus 3, that's negative 6, which is fine. So our only answer for this case is just going to be x equals negative 3, because before our x squared terms here, they actually cancel out. So there's no more, it's not really a quadratic equation no longer. So that's why you only have one solution. And that's why our answer choice would be B. This question says, if square root of w plus 3 equals to w minus 3, then w is equal to blank. So let's write our equation down here. So we have square root of w plus 3 equals to w minus 3. So whenever we're solving any type of equation that involves square roots, our first thing we want to do is we want to isolate our square root. That means we want to get it on one side by itself and everything else on the other side, which in this particular question, it's already done for us. So now what we need to do is we need to get rid of our square root, just like we said before. Is to get rid of square root is the opposite of a square root is a square, or power of 2. So you would square the left-hand side, and obviously what to do on one side, you want to do to the other. So on the left side, the square and square root cancel, and you'll have just w plus 3. Now the right-hand side, now w minus 3 quantity squared, it's not just saying squaring w and squaring negative 3. What you have to think of w minus 3 as, squared as, is just w minus 3 times w minus 3. So we need to FOIL that. So that will give us first w squared, outside is w times negative 3, negative 3w, inside negative 3 times w, negative 3w again, and negative 3 times negative 3 is our last terms, which is positive 9. So this will give us, let's rewrite everything, combine like terms. So it'll be w squared minus 6w plus 9. So we notice that we're dealing with a quadratic equation. So let's move everything over to one side. So because we have more terms on the right than we do on the left, let's move the w plus 3 over to the right side. So we do that by subtracting w on both sides. That will cancel that, and at the same time we can subtract 9 on both sides. Or sorry, not 9, subtract 3 on both sides. So that gives us, left side we know it's going to be 0. We have w squared, negative 6w minus w is negative 7w, and 9 minus 3 gives us 6. So to solve this quadratic equation, we need to factor. So think of two numbers that multiply to get you positive 6 and add to get you negative 7. That would have to be a w minus 1 and a w minus 6. So now, once we factored our quadratic equation to solve this, we set both factors separately equal to 0 and solve for x, or solve for w in this case. So we would add 1 both sides. So w equals to 1. And over here we add 6 both sides. W equals to 6. And then our solutions. So now we have to make sure these are our solutions. But we have to make sure the solutions make sense in our equation. So let's check. Okay, let's check when w equals to 1. So we plug w equals to 1 back into our equation here. So we would have square root of 1 plus 3. Is that equal to 1 minus 3 though? That's our question. Left hand side, 1 plus 3 is 4. Square root of 4 is 2. However, the right hand side, 1 minus 3 is actually negative 2. Those two are not the same. Therefore, w equals to 1 cannot be a solution because it doesn't satisfy our equation. Let us check with w equals to 6. So square root 6 plus 3, and we're checking, is that equal to 6 minus 3? So left hand side, 6 plus 3 is 9. Square root of 9 is 3. And right hand side, 6 minus 3 is 3. So that's good. So our only answer would be w equals to 6. So our solution would be just 6. Therefore, our solution is just 6, and which is answer choice C. Okay, so now we're still in the realm of quadratic equations, but specifically, we need to understand the graph of quadratic equations. So the question gives is, given f of x equals x squared minus 4x plus 3, find the minimum of the quadratic equation. So to understand what a minimum is we need to understand what the physical graph of a quadratic equation is. So the graph of a quadratic equation is what's called a parabola, and that's given in the shape of kind of like a U, has this U shape here, but that's if it's your parabola's positive. If it's negative, it's an upside down U. So the minimum value is, we're looking at this left one here, is this little bottom point here. Now this bottom point is what's called our vertex. Vertex is the lowest point on a positive quadratic function. So to find that is, let's go back to refer to what our standard form of a quadratic equation is. Ax squared plus bx plus c. Now, oftentimes the vertex can be represented as some h and some k value, where h is like the x value and k is the y value. So when your function, your quadratic equation is written in the standard form, ax squared plus bx plus c, we can find the vertex by doing, we can find the h value by doing negative b over 2a. And in doing so, once we get whatever that is, we take that value, we plug it back into our equation to find the y value or the k value. So to find the minimum here, it means we're trying to find the vertex. So first thing we do is we need to identify what is our a and what's our b. So our a would be 1, because the coefficient in front of the x squared is 1, and the b would be negative 4. So first thing we do is to find the vertex. We would find the h value of the vertex, and we do negative b over 2a, which is like saying negative 4 over 2 times 1. So that would be a positive 4 over 2, which gives us 2. So h would be 2. So to find k, we would plug 2 into our function here. So we do f of 2. That means everywhere of an x, we replace it with 2. 2 squared minus 4 times 2 plus 3. So we evaluate that. 2 squared is 4. Negative 4 times 2 is negative 8 plus 3. So 4 minus 8 is negative 4 plus 3 is a negative 1. So that would be our k value. So that means that our vertex would be the coordinate point 2, negative 1. So that's our h, which is our h and our k respectively. So that would be our vertex, aka our minimum value, or minimum point, which is why we get answer choice A. In the same vein, we're given another quadratic equation, and we want to find the vertex of it. But this time, it's written in a different form. It's not written in the standard form that we've been used to. Now, this form is actually a very specific form. This form is actually the vertex form of a quadratic equation. So the vertex form is written as f of x equals to x minus h squared plus k. There we go. There's that h and k again, where again the vertex can be represented as h comma k. So if it's written this way, all we need to do is identify what our h and k is, and that will give us our vertex. So we look at our function x minus 2 squared plus 3, we can see that our 2 here is our h, and then the 3, positive 3, would have to be our k. So be careful that because the vertex form by default has a negative here, it's a minus h. That means when you see just minus 2, your h is just 2 itself. So our vertex would just be the coordinate point 2, 3. So all we need to do is just, knowing the vertex form, identify what our h and k are. And that gives us answer choice D. Now, this question involves us to match each function to its corresponding graph. So what we want to look at is, first thing is we want to think about what type of parent function these graphs are of. So the parent function of these graphs are the absolute value. So when you say f of x equals to absolute value of x, what that graph looks like is right at the origin here at 0, 0, it has kind of like a V shape. So we have to think about what is happening compared to the parent graph and the given graphs here. So if we look at each function, so let's look at a here. the absolute value of x minus 2. So when you have a minus 2 on the inside, you want to think of these as parentheses. Inside the parentheses, it's actually moving it horizontally. So, but if it's saying negative 2, it's actually moving 2 to the right. So this is moving 2 to the right. So if you're at the origin here, you're moving 2 units to the right, that should be graph number 3 here. So this should be graph A for choice A. For B, we have x plus 3. So again, that's plus 3, but you're actually moving to the left 3. So this is 3 to the left. So that would be the number 4 here. So that would be B. For C, f of x equals the absolute value of x plus 1. So now the plus 1's on the outside. So that's 1 up. So you're shifting the graph up 1. So that would be graph number 1 here. So that would be function C. That was answer choice C is graph number 1. And then for D, we would have absolute value of x minus 4. So that would be shifting 4 down. That would be this one right here. So see, it's shifted down right there. So that would be answer choice D.